how do you automate the monsters within your PCU? There we go. Now, so you go to the simulate tab here, and then you do two things. One, you turn auto propagate on, and then if you see here, it says auto tick enable, right? Now you can set the tick frequency. If you're in a rush, you can set it higher. I normally set it to half hertz or 1 hertz, right? Because that's gives me enough time to trace it on a step-by-step basis. And then you can also count the number of clock cycles. So, you know, when I first started running this, so if you saw this outline that you've seen, by the 5th clock cycle, where were we? We were only at a point where we could read information into the MBRs, right? But now I think by the time I got to the 6th clock cycle, I already have all the information in my registers. But I went down essentially from about 11 to 12 clock cycles to about 6 clock cycles by figuring out how to make things simpler and easier and better. So that's what my 8-line PCU looked like for the data fetch cycle, right? Just fetch data from RAM and bring it to the registers. That's what it looked like. And where is this? This is essentially from my ROM. Question is, how did you get here? And how do you know this is right? More importantly, how did you did you like manually type in all of these values, or is there an easier shortcut or path? Are these questions of interest to you? Would you like me to answer them? Excel plus Python? Nahi bhai. Python is not the answer to all the questions in the universe. Step by step. Ye sare kaam hum karenge, but step by step. Let's take a look at the sequence. And these are my 32 control lines, right? I said I have 32 control lines. These are my 32 control lines. What do I want to do? I want to connect them to my ROM controller, right? That's my ROM program controller. And what does my ROM program controller do? How does this work? So what this program counter does essentially is it's just my ROM clock counter. It says, okay, first tick, second tick, third tick, fourth tick, 5 tick, 6 tick, 7 tick. That's what you have to do, right? And then that's what I'm using. So if you remember, I said, you know, we need to sync up everything. This clock counter is essentially syncing up everything. I've just used a constant here for 1. I've not used a control line. And I'd mentioned this to Hasib earlier on Discord that control lines are expensive. They're very expensive real estate in the sense that, that circuitry is not free. Somebody has to then turn it on, turn it off. So if a control line is always going to be on or always going to be off, then maybe it shouldn't be there at all, or maybe it shouldn't be there in the lines that you're sort of programming. So in this specific instance, why have I just used a constant for the ROM clock counter? Why has that decision been taken? Why do you think that's the case? So less columns. We explained this in the beginning. हमने शुरू में discuss किया था कि हम clock counters क्यों इस्तेमाल करें. The ROM clock counter is basically helping me track कि मैंने कौन सी line execute करनी है in the ROM program controller. So now if you think in terms of the structure, control lines, program controller, and my clock counter that's ticking. These 3 pieces are supposed to work together, or at least supposed to work together well, but are they? So my first step is that this clock counter makes it possible for me to track which line am I reading. And what do these numbers represent? 0234B, 05D, 034, BC, 0F. These are all sequences of zeros and ones, right? And where are they going? They're going to the control lines. So that's the first step. I want you to remember these because I'm going to come back to these once we get to the final structure, right? So what you normally do is you put together these control lines or your logic or your program for these control lines. As I've used Excel, you can use some other combination. I recommend Excel because Excel makes it easier for me to track and trace what I'm doing and what I've done right or wrong. But they evolve over a period of time, right? So what I've done is, in my specific instance, I've simply made an Excel spreadsheet, and I've also color coded it because it's easier for me to sort of look at things, just at a high level without actually worrying about, I can just look at the controls and say, oh, this is what this is for. So if something is on or off, the color can just point out. So if you see this right now, in my Excel spreadsheet, I've got a couple of components. The first is obviously the labels. Where do these labels come from? They came from the control lines. Which control lines? These control lines. These are the labels that I've used in the Excel spreadsheet. That's the first part. Then I've got clock cycles. So these are my clock cycles. This is 0, clock cycle 0. This is clock cycle 1. This is clock cycle 2. This is clock cycle 3. This is clock cycle 4. And then I'm saying, पहले clock cycle में सिर्फ instruction RAM का OE on होगा. बस that's it. And MBRZ का write enable on होगा. और MBRZ का write enable MARZ का. So MBRZ का भी and MARZ का भी. So MBRZ and MARZ is what? MBRZ is memory buffer register for memory 0 instruction or system, and MAR is memory address register. तो ये on होंगे, बस बाकी सब off होंगे. So this is what? This is instruction RAM to MBRZ, the first part. Then instruction RAM to MBRZ, the second part. फिर मैं क्या करूँगा? फिर मैं और कौन सी लाइन ऑन की मैंने? अब इसके बाद मैंने इंस्ट्रक्शन स्प्लिटर को ऑन कर दिया, एंड MBRZ का जो कंट्रोल बफर है उसको ऑन कर दिया. So that's 2. थर्ड इज क्या? फ्रॉम MBRZ टू इंस्ट्रक्शन स्प्लिटर, राइट? अब MBRZ से अब इसमें क्या चेंज करना पड़ेगा? तो नाउ इफ यू सी द सम, इसमें 4 लाइनें ऑन है सिर्फ, इसमें 6 लाइनें ऑन है, इसमें 12 लाइनें ऑन है. And this is how you build it step by step. So you sort of put these labels together, put in the zeros and ones, and then concatenate them. And when I concatenate them, I get this big giant number of, or series of zeros and ones, and then I convert them into hexa, and you can do them in Excel. So Hasib shared that model, was not very happy with sort of doing it on that basis. So I just use an online converter. I just take this series of strings and I copy them and then convert them and then copy them right back. And this basically gives me this. So you see 02084001, 02084001, 208C001, 208C001. Control lines, and these control lines are essentially what we need to turn on and off. That's the step number 1. These control lines have to be synced with the clock cycle. Before, with our presentation, when we were sort of walking through the flow, what were we doing? We were stepping into the program on a step-by-step, clock cycle by clock cycle basis. We're saying, this is what I'm going to turn on, this is what I'm going to turn off, and this is how the state of the circuit is going to change from one clock cycle to the next clock cycle. Who is changing the state? We are changing the state. How are we changing the state? We're changing the state by turning things on and off. So this is step number B. The third thing that you have to do is that you have to track these cycles or these signals for the duration of the execution. So now if you think in terms of the flow, right? How does the flow work? You remember the flow? It goes from MARZ to the instruction RAM, but it takes time, right? So that's one clock cycle. So now you're on clock cycle number 2. Now, how do you get from the instruction RAM to the MBRZ? So that's the third clock cycle. How do you get from MBRZ to the instruction splitter? That's the fourth clock cycle. How do you go from instruction splitter to the MARS? That's the fifth clock cycle. How do you go from the MAR to RAM A and B? That's the sixth clock cycle, and then the seventh clock cycle, and then the eighth clock cycle, and then the ninth clock cycle, right? So now it's taking me 9 clock cycles to move data from my RAM to the adder or multiplier or ALU that will do some kind of logical or mathematical operation on the data that I've fetched. But that means that for this to happen within those 9 clock cycles, I have to turn doors on and off. I have to turn buses on and off. I have to turn elements and controls and components and units on and off. I have to turn write enable on and I have to turn write enable off. I have to write output enable on and output enable off. So I can't just do it randomly. I have to do it in sync with the clock. The circuits understand the clock, the components synced with the clock, so I have to sync my activity also with the clock. And that's the reason why I have to trace it step by step, clock by clock. Identify the control lines, that's step number 1. Then we've identified the signals that need to be turned on and off, and we've identified them with respect to a given clock cycle. So that's done. So it's essentially 1, this is 2, and then the clock cycle itself is 3. And then when I take all of these ones and zeros, all 32 of them, what do I end up with? I end up with this big, giant, really awkward collections of zeros and ones that make no sense to me at all. So what do? To make it easier to work with, I convert them into their equivalent hexadecimal representation. It's just a condensation, right? Just representation. Just take that binary, because I cannot imagine looking at so many zeros and ones for such a long time. I just convert them into something which is a little bit more familiar to me. And I'd rather work in hexa than work in binary, which is the reason why I take this string, this binary string, and I find the hexa equivalent for it. And then this hexa equivalent is what I type in or store or load. If you prefer to work in binary, you don't have to work in hexa, as in you can just stay in binary and work in binary, right? The sad news and the bad news and the hard news is this is what my string looked like at Saturday noon. And there's a reason I'm showing this to you, right? The reason I'm showing this to you is, again, don't beat yourself up. Don't be too hard on yourself. If you say, oh, everybody's gotten it right and I haven't gotten it right, and I'm struggling and everybody has it easy. No, nobody has it easy. Everybody's struggling. So this was me yesterday. This was me at midnight yesterday. And this was me this morning at 11 a.m. Do you see the change in the strings? Even now, if you look at this, you'll find that the program that I'm running, or the program control unit that I have in ROM, has a different set of hexa strings. Welcome to computer science, Hasib. Welcome to computer science. It's not dark, it's just binary. Sorry, I couldn't resist it. It's just a very, very loose ball. So what was the mistake? What was the error? What was the change that happened between Saturday and Sunday? What was the bug? And how did I find it? This is the circuit that works, by the way. How is this different from the one that I showed you earlier? So my biggest problem, and I'll tell you what happened, what was really, what spent 8 hours trying to figure out was that even though I had set up the right instructions, I couldn't get the MBR Zika control buffer and I couldn't get the instruction splitter right enabled to turn on at the same time, even though I'd mapped it and I'd set it. So in this specific instance, you can see, okay, it's working, right? But in the previous instances, it wasn't working. Yeah, copy pasted wrong, buffer left there, changing the location of the buffer. This is Saturday. This is Sunday. Notice anything now? There you go. There you go. That's all it took. But it took me 11 hours to figure it out. And I did everything. I went back to my Excel. I sort of looked at the numbers. I rechecked the conversion. I looked at the hexa translator. Everything. And somebody actually pointed out, have you checked the MSB, LSB, right? MSB is most significant bit and LSB is least significant bit, right? It was an MSB, LSB mismatch. And that's going to happen to you also, right? So, and it happens every time. So I think I'm on this specific circuit, I think this is the third or fourth time I've done this. I think that's the default error I make. I always confuse or I mix up the order of the bits or of how I sort of connect to the wires. Even though, I tell you about it that this is an error that happens on a regular basis, it's going to happen with you also. Did the circuit finally work? Yes, it did. And how do you know it worked? So, 03FF and MBRZ, and then I have A's and B's in my memory buffer register. And I just have to move these to the register banks. Right? That's the part that's left, and that's the part that we'll figure out to do it together.